be taking more examples on definite integrals. And remember that when we have format of x, b, a, where b is the upper limit and a is the lower limit, we're going to substitute the upper limit first and the lower limit will be subtracted from it. So let's take more examples. So we are given the question to integrate from pi over 6 to pi over 3 of 2 sine 2 theta with respect to theta. Now in this case, pi over 6 is the lower limit, pi over 3 is the upper limit. And we are going to expect it to integrate 2 sine 2 theta. You can pause the video now to give it a try. And then let's proceed. So 2 is a constant. Let's bring it out. So this will give us pi over 6, pi over 3, sine 2 theta d theta. Let's recall that when we are integrating sine, let's say 2 theta or sine 8 theta with respect to x, we will be having minus 1 over a cos ax. Now, this will give us minus 1 over 2 cos 2 theta from pi over 6 to pi over 3. Now let's multiply with the constant, and that will give us minus 2 over 2 cos 2 theta from pi over 6 to pi over 3. And this will give us minus cos 2 theta from pi over 6 to pi over 3. Now we are left with the job of substituting the upper limit and the lower limit. So substituting the upper limit, which is pi over 3, we have minus cos 2 pi over 3. And substituting the lower limit, we will have minus sine minus cos 2 into pi over 6. And when we plug this into our calculator, we will have our answer to be equals to 1. Let's take another example. We are asked to integrate with respect to x from lower limit 1 to upper limit 2 of 4 exponential 2x dx. So the first thing we do is to bring out our constant, exponential 2x dx. And we recall that when we integrate exponential ax with respect to x, our answer will be 1 over a exponential ax. Now a in this case is 2. Just like we've been here before, this will give us 1 over 2 exponential 2x from limit of 1 to 2. So this will give us 4 over 2 exponential 2x from 1 to 2. This will give us 2 exponential 2x from limit of 1 to 2. Now we'll begin to substitute our exponential, our upper limit and the lower limit. So this will give us 2 exponential 2 into 2 as the upper limit, and this will give us 2 exponential 2 into 1 as the lower limit. So it gives us 2 exponential 4 minus 2 exponential 2. And simplifying this with the calculator, we will have 94.42. Let's take another example in this format. Let's integrate from minus 1 to 2 of 2 divided by 3 exponential 2x dx. Now the first thing to do in this case is to make it in the format of integral exponential ax dx. And doing this, we have to apply the law of indices such that this will give us 2 over 3 exponential minus 2x dx. That means we're applying the law of indices. And integrating exponential ax with respect to x, we'll have 1 over a exponential ax. So we can bring our constant out from minus 1 to 2 exponential minus 2x dx. And integrating this, we will have 1 over minus 2, because a is minus 2, exponential minus 2x, from our limit of minus 1 to 2. Now let's multiply out. Therefore, this will give us minus 1 over 3 exponential minus 2x from limits of minus 1 to 2. And now we can put in our limits, our upper limit first and our lower limit. So our upper limit is exponential is 2 minus our lower limit, which is minus 1. So simplifying further, this will give us minus 1 over 3 exponential minus 4 minus into minus 1 over 3 into exponential 2. So when we plug this in into our calculator, we will have 2.457. Let's take another example. Number 4. Let's integrate from 1 to 4, 3 over 4u du. Now this brings us back to integrating 1 over x dx to give us ln x, because this 1 over 4, 3 over 4u, the same thing as saying 3 over 4 multiplied by 1 over u du. And integrating this, we will have it. We can bring our constants out first for more understanding. Then we will have 1 over u du. Now integrating 1 over u, applying this principle, will give us ln u from limit of 1 to 4. That's 3 over 4 from ln 4 minus ln 1. And that will give us 3 over 4 into 1.3863, and logarithm of 1 is 0. Now our answer will give us 1.040. Let's take 2 more examples. 5. Integrating from 1 to 3 of 2x squared minus plus 1 divided by x dx. Now the first thing to do is to simplify the function and break it into more terms. And that's 1 3 2x squared over x plus 1 over x dx. So it gives us one integral from 1 to 3 of 2x plus 1 over x dx. And now let's integrate 2x plus 1 over x with respect to x, and we'll have 2x squared over 2 plus ln x. from 1 to 3. And simplifying further, we have it to give us x squared plus ln x, limit from 1 to 3. So the first thing to do is to substitute our upper limit. That's 3 squared plus ln 3. And we subtract our lower limit of x is equals to 1. That's 1 squared plus ln 1. Putting this in our calculator, we will have our final answer to give us 9.099. One more example. Integrating from pi over 4 to pi over 2 of 3 sine 2x minus 2 cos 3x dx. Now we know that our upper limit is pi over 2 and our lower limit is pi over 4. Then we'll be expected to integrate 3 sine 2x, likewise 2 cos 3x. Therefore, integrating 3 sine 2x, before we continue, let's write out the principles. That's integrating sine ax with respect to the x, we would have minus 1 over a cos ax, and integrating cos ax with respect to x, we'll have 1 over a sine ax. Therefore, integrating 3 sine 2x, we'll have 3 as a constant, and our a is 2 in this case. So we are going to apply this. That's into minus 1 over 2 cos 2x minus 2, and integrating cos 3x, we will apply this principle. And our answer will be minus 1 over 3 sine 3x. And we apply our limits from pi over 4 to pi over 2. Therefore, this will give us minus 3 over 2 cos 2x minus 2 over 3 sine 3x from pi over 4 to pi over 2. Now, we substitute our upper limit. First, our upper limit is pi over 2 and our lower limit is pi over 4. So this gives us 3 minus 3 over 2 cos 2 into pi over 2 minus 2 over 3 sine 3 into pi over 2. This is the upper limit, minus substituting the lower limit of pi over 4. That gives us minus 3 over 2 cos 2 into pi over 4 minus 2 over 3 sine 3 into pi over 4. Now simplifying further, we have minus 3 over 2 cos pi minus 2 over 3 sine 3 pi over 2 minus into minus 3 over 2 cos pi over 2 minus 2 over 3 sine 3 pi over 4. Now, after simplifying all of this, we'll have our final answer to give us 2.638. Now, we have been able to understand how to integrate indefinite integrals and definite integrals. Now, we'll be taking a look at the applications of integration. So in our next video, we'll be considering area under and between curves.